easy detect. In this video, we'll continue the problem which we were solving in the last video. The last video we were solving this analysis of rock cantilever. We were able to find out the reactions, and we were able to find the shear force. We were able to draw the shear force diagram, and we have found out where exactly we'll get shear force equal to 0. Now let us continue the same. Here we got like 3.75 meter as well. As our value for shear force equal to 0. Where exactly 3.7 meter lies. So this is the value 3.7 meters. Okay. What is the remaining value? If we take the distance from A end, it is 3.75. If we take the distance from B end, then it will be 0.25. So it depends on while considering the bending moment, either you are taking from the left hand side or from the right hand side. Now let us continue the same. So we have found out to draw the shear force diagram. Now we need to draw the bending moment diagram. So this is our fifth step. Bending moment diagram. So how to draw this bending? It is very simple. First, we need to be very clear about the beam and its loading and its reactions. So we have RB, we have RA. So RA is nothing but 37.5, RB is nothing but 30.5. We have moment of 45 kilonewtons. We have 8 kilonewton as our point load, 10 kilonewton meter per meter. We have found out that the bending moment will be maximum at 2.25 meter from the left hand side, 3.75 meter from right hand side. Okay. Now, first of all, I will draw the beam. This is my point A. This is my point. At point A, at x equal to 0, my bending moment A, point A will be the same as the moment which we have got in the reactions, that is 45 kilonewton. So there will be a straight line, 45 kilonewton meter. Now at point B obviously it will be 0. So let us find out the maximum bending at this location. It will be coming at this location. I don't know whether it is positive or negative as of now. So let us, to find that, we can take this one same thing. We'll take that from the right hand side. It will be much easier. We are standing here. We know the reaction here, know the load, everything. So let us take that. So now at x equal to, since we are taking on the this thing from the right hand side, it will be 2. So 2.25 meters. This will become 30.5 reaction is there. Okay. Let us write in terms of equation so that it is clear. So we have RB at a distance of 2.25 meter. Okay, then I have a UDL acting on this. Yes, same thing. 10 kilonewton. So that is kilo. X 10 into x this distance into x by 2, it will be acting at center of this. So substituting this value and minus 8 kilonewton is acting at 2 say into x. This will also I'll write in terms of x so that this equation will be helpful in the future. So RB into x, that will be m 2.25. So now moment at 2.25 equal to what is my RB? It is let us write in terms of this one 30.5 x minus 10x square by 2 minus 8x. This is the equation. If I substitute this 2.25 here, so this will be 30.5 to 2.25 minus 10 into 0.25 square by 2 minus 8 into 2.25. Solving this, we'll get 25.31 kilometer. Okay, so this is how we need to get the moment. So we took all the roots on the right hand side. This is, I consider this one as my x, and in the terms of x we substitute 2.25. So this is the value we have got. Now for UDL we already know it is parabolic curve, the bending. We know this is 45 here. We know this value is 25.31. From this value is 0 because of a property. The bending moment which we'll get is like this. So it will start from, so, and since this is parabolic curve, so it will be, it's not triangular actually. This is actually smooth curve. Like this. Now we need they will also ask us to find the point of variable bending moment 0. We can make use of the same equation. That's why we had developed this equation in terms of x so that we can easily find out this one. So now point of contraction. Call this one as point of contraction. This point of contraction, what we'll do is we'll equate this equation to 0. Why? We need the bending moment is 0. So here m0 equal to 30.5 2x minus 10x square by minus 8x. That should be 0. Solving this will be 3.5x plus 5x square is 8x, that equal to 0. And 8x 31, this will give minus 5x square. Subtracting this 30.5 minus 8, it will give 22.5 x, that will be 0. Okay. And substituting this value, x square minus x square 22.5 x 5 x gets cancelled. The x value will be 4.5. This is negative. What is this negative indicates? The value which they have got is this value, this value. This is the value, it is 4.5 meters. So from in this direction, from 6 meter, if I subtract, it is 1.5 meter. Okay. So let me give the shear force in and how it is after plotting it. So this is my shear force diagram, and this is my bending. So with this, we have found out reactions, we have found out shear force and plotted shear force diagram at this bending moment. The third and important thing which they ask us to find out is deflection. So this is the sixth step, the analysis, find out the deflection. Okay. We already know that moment is nothing but EI to d square y by dx square. This is the moment equation. And here we have also developed this moment equation. What is that? This is the equation. This is the moment equation we have developed. This is very helpful in this case. What is that? That is 30.5x reaction 30 into 5.x minus 5x square is 8x. This is the equation we have developed. Now we'll equate this one. And why do we need to equate it? We need to equate it. Why? Because if we integrate this twice, this will give us directly the deflection. That is the reason we need to equate it. This moment, you'll get EI d square y by dx equal to 35x minus 5x square minus 8x. So here, this y is nothing but the deflection, and I am interested in finding out the deflection. Right? So that is why I equated it. I will name this one as third one. Integrating equation 3 with respect to x. What is this x? Here x is nothing but my distance. This distance varies in this proper cantilever. It will vary from 0 to 6 meters. Okay. So we are integrating this equation. So when we integrate this one, then what will get? EI dy by dx, integrating the differentiating, this will get dy by dx. Okay. We can even simplify this equation, that is 22.5 x square by 2 minus 5x cubed by 3 plus c1. These are the basic of integration. I will name this one as 1. Okay. Again, once again equating, this is nothing but the slope. If I send EI on the other side, this is my slope. Repeating this integration, integrating equation 1 with respect to x. So we'll get y EI1 is equal to 22.5 x cubed by 2 to 3 minus 5 x power 4 by 3 into 4 plus c1x plus c2. This is equation 2. Right? So we have developed these two equations. Now what do we do? Before proceeding forward, we can substitute the value here and we can get this slope and deflection. But there are some constants C1, here C1 and C2. Before substituting the values, we need to find these constants. The whole procedure, whatever we are using here, integrating it twice, this is known as double integration method. There are many methods to find out this deflection. This is a very easier method we can directly get easily with this bending moment equation. That's why I followed it here. Now, how to get this C1 and C2? To do that, we need to once again draw the figure of this proper cantilever. This is my A. Now, at x equal to 0, that is at this point at A x is 0, what will my deflection? So it is preventing my deflection, right? It is preventing my vertical movement. That is why we are getting reaction. So my deflection 0. What about my point at B? That is x equal to L. What is my y value? Point B also it is preventing my deflection. So it is also 0. So these values, whatever I have written, that is known as boundary conditions. Okay. So if you have any support in it, definitely you'll get these boundary conditions. What are those boundary conditions? Is A is at x equal to 0, y is 0. And what is my B boundary condition? At x equal to L, y equal to 0. Why do we need these boundary conditions? If we substitute these boundary conditions, we might be able to get this constant C1, C2. Okay. Substituting this value in equation 2. Substituting, let me change my substituting A boundary condition, that is x equal to 0, y equal to 0 in equation 2 we'll get, so here y is 0, ei is to 0 is 0, then here we got 22.5 into 0 by 3 just 6 minus 5 into 0 4 it is 0 also 0 12 plus c1 into 0 plus c2. Solving this, since every component here is 0 except c2, so c2 will be 0. This is the important one. So the c2 value is 0. Substituting b is that at x equal to L, y equal to 0 in same equation 2. So if we substitute this ey 0, what is that value? 22.5 into, instead of x we need to substitute the L, it is L cubed by 6 minus 5 into L power 4 by 2 C to L C2, that is 0. Simplifying this, so C1 L equal to, so we need to take out this here, that is 22.6. Okay. So here we'll get 5 L power 4 by 2 minus 32.5 into L cube 6. Okay. Taking L common and simplifying it, we'll get C1 equal to 5 L cubed by 2 minus 32.5 square 6. So this is the C1 constant. Now substituting this C1 and C2 in equation, now let us substitute the value in the equation 2. Okay. So substituting C1, C2 in equation 2. So this will get EIY equal to 22.5 x cubed by 6 minus 5 x power 4 by 2 plus I can directly substitute this c1 in. So, sorry, this is in x, not here. So it is c1 into x. That is what equation 1. It is c1 into x. So we'll substitute c1 value 5 by 2 is 22.5 square 6 to x. Now this is the equation. From this equation we can directly calculate the deflection. Now we need to find out the maximum deflection here. So when will be my maximum deflection? How to get this maximum deflection? To get this maximum deflection, we know that theta should be equal to 0. At theta equal to 0, my deflection will be maximum. So we know the theta equation, that is equation 1, integrating towards this equation. If we equate it to 0, we get the x value. Substitute the same. So from equation 1, what is this equation? 22.5 x squared with 2 minus 5 x cubed 3. Now we need to substitute the c1 value also here. That is plus 5l cubed minus 22.5 l squared by 6. Okay. This value should be equal to 0. Right? Now we need to calculate this x value. How to calculate this x value? It is 22.5 square by 2 5 x cubed by 3. Now here we'll substitute the values here. That is L equal to 6 meters. This is the overall length. So 22.5 into 6 square by 6, 6 cancel, minus 5 into 6 cube, 12. So simplifying this, we'll get the x value after simplifying, we'll get, that is, we'll get the three values here. One is 1.77 minus, next is 2.53, next one is 5.9. So we need to judge which value is correct. Obviously negative value is wrong, and 5.98 is nothing but it's equal to 6, where at that point deflection is 0. This is also wrong. This will be the case where we'll get the maximum deflection. So we'll take this value. This is solving equation. Since this is cubed root, we'll get 3 values, and among 3 values we need to judge which one it is. Substituting this value, see the equation 2 the x value, that is 22.5 into 2.53 whole cube by 6 minus 5 into 1.53 square by 2 is 5 into 6 square by 2 is 2 into 6 square by 6 into 0.53. So this is EIY. Solving this, y value get 70.6 by EL. So you may ask why it is so much, so large deflection. So it is not large deflection. Actually, we haven't divided it by EA. So if we divide it by EA, we'll get terms of in terms of meters. Okay. This is how you need to solve a problem, proper analysis of proper cantilever. So in the exams, they won't ask you do this much longer problem They will ask only components of this to either to find out the reactions or find out the bending moment or shear force or the deflection. Either of these three they will ask in the exam. Hope it is clear. If you have any doubts, please feel free to comment in the comment box. Thank you.